Hi everyone, today we have learned basic concepts of Verilog. First, what is VLSI? VLSI stands for Very Large Scale Integration. It is the technology of integrating millions or billions of transistors onto a single chip. If we take a single chip, we place millions or billions of transistors onto the chip. Enables complex electronic systems to be small, fast, and power efficient. For example, in olden days, we see that computers were very big and slow. Nowadays, small and fast. This VLSI is used in processor, memory chips, GPUs, and SoCs. This VLSI is foundation of modern electronics and digital devices. Next, we move on to the VLSI design flow. In VLSI design flow, we have specification, architecture design, RTL design, functional verification, synthesis, physical design, timing and power analysis, fabrication and testing. Specification is the first step in designing a chip. In this step, we decide what the chip should do, how fast it will be, how big and how much power it can use. We also decide the number of inputs and output pins. The second stage is architecture design. Architecture design in the VLSI flow is the stage where the overall structure of a chip is planned based on performance, power, and area requirements. It defines the major blocks, data flow, and interaction before RTL code begins. Next stage is RTL design. RTL design is the stage where the chip's behavior is written using hardware description languages like Verilog or VHDL. It explains how data moves between registers and how the circuit works on each clock cycle. The next step is functional verification. Functional verification is the stage where we check whether the RTL design works correctly according to the given specifications or not. It ensures the design produces the right output for all possible inputs before moving to the next stage. Next stage is synthesis. Synthesis is the stage where RTL code is converted into a gate level netlist using logic gates based on timing, power, and area requirements. Next, we have physical design stage where the synthesized gate level design is turned into a real chip layout by placing and routing all the cells while meeting timing, power, and area. Next, we have timing and power analysis, where we check if the chip meets speed requirements and stays within power limits under real conditions. Next stage is fabrication and testing. It is the last stage where the chip is manufactured in a foundry and tested to ensure it works correctly before deliver. Next, we have Verilog basics. Verilog is a hardware description language used to design digital circuits. The basic building block is called a module, which has inputs and output ports. Signal can be of type wire for connections, reg for storage. In combinational logic is written using assign, while always block are used for sequential or combinational operation. Next, we have module and ports. In Verilog, module is the basic building block of a design. It defines the inputs, outputs, and internal logic of the circuit. For example, AND gate can be written as module where A and B are inputs, Y is the output. Ports are used to connect signals like input port, output port, in out. Input brings signal in, output sends signal out, in out is bidirectional. Next, we move on to the Verilog code for all gates. In Verilog, AND gate can be created using a module where two inputs A and B, output Y, A and B are combined to give an output Y using assign statement. Assign Y equal to A and B. At last we give the N module. Similarly, we have write for OR gate also. OR gate uses the assign Y equal to A or B. To combine these inputs, the output will given to the Y. Like that you can try for all gates. Next we move on to the modeling styles in Verilog. There are three modeling styles: gate level modeling, behavior modeling, and data flow modeling. Gate level modeling in Verilog describes circuits using built-in primitive gates like AND gate, OR gate, NOT, and NAND. It focused on how the gates are connected rather than the writing logical expressions. For example, an AND gate can be made using primitive AND gate. This method is useful for low-level design or synthesis. First, see this example. Module AND gate defines the AND gate module. Input A, B. Two input signals. Output Y. It will be output signal. AND Z1 YAB uses the built-in AND gate primitive named Z1 to connect input ports A and B to get output Y. Next, we move on to the data flow modeling. The data flow modeling in Verilog describes how data moves through a circuit using operators like AND operator, OR operator, NOT, XOR. It focuses on what the output should be rather than the gates used. For example, AND gate can be written as assign A and B, which tells the compile how the output Y depends on input A and B. Next, we move on to the behavioral modeling. It describes the behavior of a circuit using always block. It can be used in combinational or sequential logic and focuses how the circuit behaves rather than the gates or assignments. For example, AND gate can be written with an always block where the output Y is assigned A and B, showing its behavior directly. Thank you.